What's up, logic fans? It's Ash again. Bivalent Logic Explained, section 1.8, Propositional Symbolization 6, Substitution Instances. This is our final section in chapter 1 on propositional symbolization. Let's rock. Alright, so let's remind ourselves where we were at last time. Okay, we have all of our symbolizational apparatus completely now. We've got our propositional variables, the constants, negation, conjunction, or, if then, biconditional, tribar, and the grammatical devices left and right parentheticals. So we saw in the last video, 1.7, that we can prove, for example, that this string here is in fact a form. Alright? And we can prove that it's a form by producing a form tree, like so. This is all covered in the last video. It's just review, and it shows you how the parentheses work and how all these different symbolization, symbolization devices, all of this machinery works together in a very formal way and shows what is a propositional form and what is not a propositional form unambiguously. What we're going to do today is first we're going to show how we can develop not propositional forms but propositions. Different thing, okay? And it's going to be very similar to this. And then we're going to show some interesting stuff about the relationship between propositional forms and propositions, which we will require for later work. And that will conclude our study of propositional symbolization. So let's jump right in. So the first thing we need to do is rigorously define what a proposition is. Now, we've got this big nasty thing here, but just as in the previous video, this looks a lot nastier than it is. In fact, it's even easier because this follows the exact same structure as the last video on propositional forms, except now we can define what propositions are, and it works the exact same way as forms, but instead of using lowercase p, q's, and r's, right, we use uppercase A, B, C's, and D's. And other than that, everything is the exact same. So let's do an example and just follow the same procedure you did from 1.7, except instead of using lowercase letters, P, Q, and R, use uppercase letters and prove that this is in fact a proposition by application of these rules. Notice we use P1, P2, and P3 instead of PF1. Propositional form 1, propositional form 2, we just use P1, proposition 1. Pause now and see if you can't solve this one. Alright, let's do it together, so hopefully you've had a chance to do it. And look, it just proceeds in the exact same way as in 1.7. So if you're having trouble with this, look at 1.7 for all the reference points. But it follows the exact same pattern, alright? And we use the same sort of notational conveniencies regarding the omission of parentheses in certain cases. So technically there should be a couple of parentheses here, right, and so on, and certainly down here there should be another row of parentheses here if we're following the strict interpretation of these rules, if we're being MIT meticulous about it, okay? But no, we're just going to sort of omit those for readability purposes, and that's absolutely fine. And just to really drive the point home, let's take a look at this. And just to really emphasize the point so that you can see it clearly, I've put these side by side. So proving that this expression is a form and proving that this expression is a proposition, right? It's the exact same procedure, only you're using capital letters instead of lowercase letters. So again, if you have any questions about this, see the video on 1.7. Alright, we have formalized the notions of a form and the notion of a proposition. So we've got both those on board, ready to go. So now what I want to do is I want to define the notion of a substitution instance. Rather than formally defining it though, let's introduce the concept via example. So looking at this example here, the idea is to substitute the propositions into the forms, okay? So here we're letting P stand for, the form P stand for the particular proposition A or not B, and we're letting the form Q stand for the proposition not D. And the idea is that you're supposed to substitute these values into these expressions and figure out what the resulting expression is. For example, the answer to 1 would be A or not B. So using that information and not defining the concept of a substitution instance formally just yet, see if you can't go ahead and do this example. Pause now, give that a shot. We'll come back together and do it. All right, hopefully you've had a chance to ponder this. Let's go it out. So substituting this proposition into the form P, we get A or not B. Okay, very straightforward. These should all say star. These are the answers. We've got not P, so what we're going to do is we're going to write not, and then the P thing, which is right here, so we get not. It's not the case that A or not B. And we would say that this is a substitution instance of this, right? This is a substitution instance of this, and so on and so forth. But before we get into that, let's just keep working here. Here we have an expression P and Q, so we're going to substitute the P part, A or not B, write down the and then write down the Q, which is not D, right? Now, here things get a little bit trickier. Instead of P and Q, you've got P and P. So it's going to be A or not B and A or not B. Okay, and this draws our attention to various aspects of the formal definition of a substitution instance. All right, let's try this one. And I'm not formally defining the notion of substitution instance. I'm going to, but I'm just trying to get you a feel for the concept by example. So here what we have are 5 propositions. Notice you could prove each of these are propositions by doing a proposition tree. Okay, so these are all propositions. Each and every one of these 5 propositions is a substitution instance of this form. Now, you don't know exactly what that means yet because I haven't defined it. But what I want you to do is I want you to tell me, for this substitution instance of this form, tell me what the value of P, Q, and P. There's only P, Q, and P. Okay, so there's just P and Q to think about. What is the value of P in this substitution instance of this form? Okay, so let's do this one together so you know what I'm saying. This one, the value of P is just A, and the value of Q is just B. So P is A, right? Q is B, and notice A shows up again right there as P. Okay, so see if you can do that for 2, 3, 4, and 5. Pause now and give that a second. What's the value of P in this substitution instance? What's the value of Q in this substitution instance? What's the value of P in this substitution instance? So on. Okay, for all of them. Pause now and we'll give that a shot together. All right, hopefully you've been able to work it out. Let's look at number 2 together here. So we've got our solutions. The value of P in this case is just B. The value of Q is C. And notice, if you just sort of copy and paste, right, B into this, C into this in the appropriate place. B replaces P everywhere it appears, and C replaces Q everywhere it appears. You get this. That's the notion of a substitution instance. Let's look at number 3. If P is just A and Q is also A, and you substitute it in, you get this, right? So this is a substitution instance of this form. This proposition is a substitution instance of this form, right, where P is A and Q is also A. All right, let's take a look at number 4, ramping up in complexity a little bit. In this case, P is the entire proposition F and G, right? So this right here is the P. You got the OR, right? P, OR. Then you've got the Q here, which is just the B. Then you've got the and, there's the not, P again, F and G, all right? So P does not include the negative here. That's important, okay? In certain cases it can. In this case, it does not, all right? This is the P. This is the P without it, and this is the negation right there, just as this is the and here, and that's this and right there. Okay, so hopefully you're tracking all these little details because they're going to be built into our formal definition. Okay, that's why we're doing it by example first. Okay, last case. Here we have F or G as P, and notice it appears right there as F or G again, and the negation is right there. There's the negation, okay? There's the and. There's the and. And the Q in this case does include the negative, right? There's no negation here, so we have to include it, right? So if Q literally is that, and we copy and paste this in for the Q, you will get this out of it, right? So That's why we formally defined a propositional form. That's why we formally defined what a proposition is. And now you're kind of seeing how they all fit together via this notion of a substitution instance. All right, and there's just one little last piece of machinery we need before we can sort of formally define the notion of a substitution instance, which you already have a little bit of an intuitive grasp of. Not completely, but a little bit. Let's go ahead and define this idea. So let's talk about here types and tokens. So consider this proposition. Okay, this proposition has two tokens of the A propositional constant type. So the propositional constant type A is in this. The propositional constant type C is not in this proposition, nor is the propositional constant D or E or F. Okay, only the propositional constant types A and B are in this. But the propositional constant type A appears twice, right? So you have the leftmost one, then you have the second one, then you have, maybe the third, the fourth, the fifth. We sort of name them from left to right, okay, by convention. There's only one token of the propositional constant type B in this proposition. So let me give you an example to see if you understand the language. So go ahead and try to figure out this one. For each of these propositions, identify what the constant types are in them and identify how many tokens of each constant type are in them. So pause now and give that a second. All right, hopefully you've had a chance to do that. So this proposition has two constant types, the C constant type and the D constant type. This proposition has only one constant type, the C constant type, but it has two tokens of the C constant type. This one, the leftmost one, the first one, and then the second one here from left to right. Okay. This proposition has two constant types, D and C. Okay. It has two tokens of D and three tokens of C. And we can do the same thing with little p, q, r, and s's. It works the exact same way for the propositional variables, just as it does for the propositional constants. Okay, we are now in a position to formally define a substitution instance. So let's go ahead and do that, and then actually we're going to spill it into another video. So in the next video, what we'll do is we'll formally define the notion of a substitution instance, and then we'll do lots of examples to make sure you really understand the concept, and we'll finish it off with a final interesting idea.